All right, guys. So once again, welcome to this mathematics lecture, and in this particular class, I'm just going to look at rationalization of the denominator. So we are going to look at rationalization of the denominator. So basically, when you're talking about rationalization of the denominator, we try to borrow some knowledge from SATs. So when you're trying to rationalize the denominator, we normally borrow some knowledge from what? From SATs. So let's quickly look at what rationalization is and what we are supposed to know when it comes to rationalization of the denominator. So I'll start with the definition. So to rationalize, to rationalize the denominator, to rationalize the denominator, to rationalize the denominator of a fraction, to rationalize the denominator of a fraction involving SADs, So to rationalize the denominator of a fraction involving SADs is to make, so to rationalize the denominator of a fraction involving SADs is to make the denominator free of SADs. So it's just to make the denominator, it's just to make the denominator free of SADs. Okay, free of SADs. In short, we do not want to see any square root on the denominator. So to rationalize the denominator of a fraction involving SAD is to make the denominator free of SADs. In short, we do not want to see any SADs. So I'll quickly jump onto the rules that you are supposed to follow when you are rationalizing the denominator. I'm going to look at the rules that you're supposed to follow when you are rationalizing the denominator. So the first rule is, let's say you have 1 over square root a. Okay, so if a fraction is of this form, 1 over square root a, what you need to do is as follows. What you need to do is multiply, what you need to do is multiply both the numerator, multiply both the numerator and denominator. You multiply both the numerator and the denominator by square root a. You multiply both the numerator and the denominator by square root a, such that, what you are going to do is you are going to multiply. Let's say you have 1 over square root a, where a is any number which is positive. So you are going to multiply both the numerator and the denominator by what? By square root a. So you are going to multiply it by square root a over square root a. And you surely know that 1 times square root a is what? Is square root a over square root a times square root a. According to what we learned when we are talking about SAT, the answer is what? Is a. So this expression is just telling you that there is no SAD on the what? On the denominator. So this is the first rule that you are supposed to follow when you are trying to rationalize the denominator. This is in a case whereby you have 1 over square root a. Do we have any question on this rule? Do we have any question on this rule so that we move on? Okay, no question. So let's quickly look at rule number 2. Let's quickly look at rule number 2.
I have raised my hand though.
Yes, what's your question?
I raised my hand.
What's your question?
Where you said 1 over root a.
Yes.
What if we are having a situation where maybe you said positive, a should always be positive. Do we have situations where maybe a can be a negative?
When a is negative, then that's a complex number. That's why we learned about complex number before we did the SADs.
So we have to go. So when it's a negative, we have to go back with the process of the complex, then we come back.
No, you won't be given such a situation where square root a is negative. You can't be given such a situation. Is that okay?
Oh, okay, thank you.
Yeah, actually this a cannot also be 0, because if it is 0, then this expression is undefined. Yeah, let's move on. So the next rule is let's say you have something like 1 over a plus square root b, 1 over a square root b. Okay, so what you have to do here, you need to multiply. I'm going to borrow a term from complex numbers. I'm going to borrow a term from complex numbers, though it's not the right term to use when you're talking about the rational numbers, the rationalization. So for this one, you multiply. So for this one, you multiply both the numerator, you multiply both the numerator and the denominator. You multiply both the numerator and the denominator by, like I have said, I'm going to borrow the term from rational number, because I know that term is the term which you are familiar with. So you're going to multiply it by the conjugate of the denominator. The conjugate of the denominator, yeah, that's the term I've borrowed. So you're going to multiply by a minus c square root what b, so that the denominators can be what, a difference of 2 squares, such that, so if you observe here, I've just changed the positive there, I've put a negative. If what was done was negative, I would have used a positive there, for me just to have a difference of 2 squares. So such that we are now going to have something like 1 over, let me use the same color which is on top to help you people understand what I'm talking about. So you're going to say 1 over a plus c square root b, then you're going to multiply it by what? We are going to multiply it by a minus c square root b, okay, over a minus c square root b. So this has been multiplied by both the numerator and the denominator. So when you do that, you are simply going to say 1 times that, it is simply what? A minus c square root b, okay, a minus c square root b. Then if you observe down there, it is the difference of 2 squares. If you observe down there, it is the difference of 2 squares. Since it's the difference of 2 squares, you're going to say a squared minus c square root b squared, since it's the difference of 2 squares. So when you work out that, it's just going to be a minus c square root b over a, it will be a squared and then minus square root b to the power 2. This one and that one will cancel, so it will just simply be b. So if you look at the denominator, there is no square root, so you have what? Rationalize. So these are the two rules that you are supposed to follow. Is there any questions, ladies and gentlemen? Any question before I look at the examples and we can call it a day? Any questions, ladies and gentlemen? Florence, do you have a question? Is Florence around? There's only, yeah, Florence.
Yes, I'm around.
Do you have any question?
No, I don't have any question.
Okay. Loveness, do you have any question? Oh, Loveness, you always has challenge with the network. Okay, ladies and gentlemen, let me look at the examples. Once we do the examples, then that simply means that we are only remaining with one topic to reach quiz 1 coverage. So if we can manage to finish that, that simply means that from now up to maybe up to the time you'll be reporting for classes, we are now going to be approaching test 1 coverage. In short, we are going to be done with test 1 coverage. When we are done with test 1 coverage, I'm going to shift my focus from the coverage back to revision, so that by the time you're coming to the university, you guys will know what to do and where to touch. Let's quickly look at examples. Okay, so the first example is just saying rationalize the denominator. Rationalize the denominator. So this is the first style of question, guys, and let me emphasize on this. This is the first style of question where you are asked to say rationalize the denominator, or they can say express the following. This is another way. Express the following in the form a plus c. Let's say they can say b square root c. Sometimes they will tell you. So this question in white and that question in green, they are just one and the same. They're just one and the same. So I'll start with the first one. So if the question is phrased in such a way, don't worry. The same thing I'm going to teach you is the same thing you're supposed to use to solve a question, whether it is in white or in what? In green. Okay, so let's quickly look at the example. So the example we have is 3 over, let's say I have square root 5 plus c square root 2, square root 5 plus c square root 2. So here is my approach. Okay, so I'll rewrite it as my solution. So I'm going to say 3 over square root 5 plus c square root 2. Okay, so what you're going to do is you're going to find the conjugate of that expression by just simply changing the sign there. So you're going to say times square root 5 minus c square root 2 over square root 5 over square root 5 minus c square root 2. So after you do that, you can easily work out the question, whereby you can say this is the same as 3 open bracket square root 5 minus c square root 2 close bracket over this is the difference of two squares. Remember, this is the difference of two squares. So it's going to be open square root 5 squared minus closed square root 2 squared. Okay. And then this is equal to 3 times square root 5. 3 times square root 5 is just simply 3 times square root 5 is just the 3 square root 5 minus 3 and then square root what? Square root 2. And then you say over this one, you can say square root 5 squared, it is just 5. And then you say minus square root 2 squared, it's just simply 2. So this expression, let me change that point because some people might need some questions. So there you're going to have 3 square root 5 minus 3 square root 2 over 5 minus 3 is simply what? It's simply 3. Then this expression can be rewritten as, let me change the color there just in case someone will need some question. So this can be written as 3 square root 5 over 3 minus 3 square root 2 over what? Over 3. Okay, this 3 is the same one. Then from there, if you work out that, you are going to discover that this 3 and that 3 will go, that 3 and that 3 will go. In short, our final answer is as follows, which is just simply square root 5 minus square root 2, which is our final answer. Ladies and gentlemen, do we have any questions? Any question? Please feel free to ask. Do we have any hand? Okay, no hand has been raised. Benzo, do you have any question? Benzo? Is Benzo around? Okay, Daunga, do you have a question? I can't get anyone. I don't know if you guys are still there or not. Freddy, are you?
I think for me, they'll start to talk now.
Okay. Twabona, is it clear?
Yes, that's good.
All right, thank you. Okay, let's move on.
I'm there, but next week.
Oh, I understand. Okay, the second example, I think I'll have this as my last example. Then after that, I'm going to give assignments to you guys. I'm going to make an assignment and I'm going to send it to you. I think this should be assignment number 3 for mathematics. So this one, let's say you have something like square root 3 minus 2 square root 3 minus 2 over, and then you have square root 3 minus 2 square root 5. Then I'll say solution. So what you're going to do is you're going to rewrite the same expression minus 2 over square root 3 minus 2 square root 5. Okay, so after that you're going to multiply everything by square root 3 plus 2 square root 5, then over you're going to say square root 3 plus 2 square root 5. After you do that, your next target is to just simply multiply what is on top with what is on top with what is on top, and what is down with what is down. So what is on top, this times that, this will just simply square root 3 open bracket square root 3 plus 2 square root 5, and then you say minus 2, this minus 2, then you say open bracket square root 3 plus 2 square root 5 close bracket. You say over what is down is the difference of two squares, so it's going to be open bracket square root 3 squared minus, since it's different of two squares, you're going to say open bracket 2 square root 5 squared. Okay, so with this information in mind, this is what you're going to do. Square root 3 times square root 3 is simply what? 3. Square root 3 times that is going to give you plus, since we have already learned SAT, so I'm going to make sure that I do it my calculation in my mind. So 3 times 5 is 15, isn't it? So you're going to say 2 square root 15. Okay, so we have borrowed the knowledge from SAT. Then you say negative 2 times that, it's going to be negative 2 square root 3. Then after that you're going to say negative 2 times 2 is just simply negative 4 square root 5. Alright, with that in mind, we can now simply move on, and then we go down. Down, you're going to say square root 3 squared is simply 3 minus this 2 squared, it's 4, this it's 5, so 4 times 5 is simply what? 20. At this particular point, do we have anyone with a question? Anyone with a question before I move on and look at the next part? Anyone with a question? Okay, since we don't have any question, so if you look at what is on top, okay, if you look at what is on top, all of them are what? Are unlike terms. All of them are unlike terms. If you look at what is on top, everything is unlike terms, so you can't add them, isn't it? So what we are going to do to avoid me going any further, the next step, what we are going to do is we're just going to say 3 minus 20. 3 minus 20 is what? Negative 17. 3 minus 20 is just simply negative 17. So actually let me just rewrite everything so that people will be able to follow. So what is down there, what is up there, there are no like terms, and what is down there, you can simply work it out. So what we are going to have is 3 plus 2 square root 15, and then we can say minus 2 square root 3 minus 4 square root 5 over, we know that 20, okay, let me go back, and that one, this is that. So now we have 3 minus 20, which is simply going to be what? Negative 17. So this is your what? your answer. But some people might want to multiply the negative by what is on top, okay? Some people might not want to have a negative down. So you multiply everything by a negative, just going to be negative 3 minus 2 square root 15, and then that one will be a plus, and then 2 square root 3, and then plus 4 square root 5 over 17, just in case you don't want a what? You don't want a negative down. Then this is your final answer. Ladies and gentlemen, do we have any questions on this particular question? Do we have any question? Okay, Taonga, what's your question?
How did you find 20?
How did I find 20? Okay, let me go down, let me go up. Okay, so look, 20 is coming from this part. Okay, 20 is coming from that part. So let me pick it up from there and help you understand where 20 is coming from. So this is where 20 is coming from. I'll pick it up. Please follow the red guy. Follow the red guy. I'll explain it there. So you have open bracket square root 3 squared minus open bracket 2 square root 5 squared. Okay, so what you are going to do is square root 3 squared. What's the answer, Taonga? Square root 3 squared is what? Square root 3 is 3. 3. This is where this 3 has come from, the one there. Then on the 20 part, you put a negative. The 20 part, you are going to say this 2, okay? This 2 squared, because this squared is for both of them. So 2 squared is what? 2 squared is what? Taonga. 4. So you're going to say 4. Then you say times square root 5 to the power 2, it's 5, isn't it? Like that. Then you're going to have remember there you have 3 minus, then what is inside? You're going to say 4 times 5. It's simply what? It's simply 20. So this 20 has come from there. This 3 has come, the 3 has come from there. Have you understood that part?
Yes.
Okay. Okay. Any other question, ladies and gentlemen? Let's feel free to ask. So here's now the overview of what we have learned. Okay, we have learned about rational numbers, irrational numbers, complex numbers, surds, and also now rationalization. So what happens mostly? Surds, which are helping us to understand rationalization, it gets combined with complex numbers. Surds, which is helping us to rationalize, it gets combined with what? Complex numbers. So that's where now people get stuck. They don't know how to work out such questions. All they know is rationalization alone, complex numbers alone. They don't know